Okay, the next question, what is the base of the natural logarithm function? Um, well, you're sitting there probably thinking, well, it's e because that's how the natural log is defined. It was defined as a reciprocal, as the inverse of the natural exponent. And that's right, but here's some more evidence to kind of back up. Now that we know what some calculus, we can come at this from a different direction and verify actually that the base of the natural log is the number e. So let's start this way. Let's let the natural log of x, let's think of that as log base b of x. Okay, and so we kind of are trying to figure out what is the value of b. Now, we know that the natural log of 1, okay, wait a minute. I don't want to go there that exactly. No, that's not what we know. We know that log base b of b is equal to 1. Using the properties of logarithms. So if log base b of b is 1, then I'm saying the natural log of the number b is 1. Alright, now we've defined the natural log of x as a definite integral from 1 to x of 1 over t dt. So we're going to say that the log base b of x is equal to the definite integral from 1 to x of 1 over t dt. I'm just replacing the natural log with what we're saying it's going to be equal to, log base b of x. Now, if I differentiate this at x equal 1, okay, I know the derivative of the natural log is 1 over x. So I know the derivative of log base b of x has to be 1 over x. And at x equal 1 will equal 1. You think about just plugging a 1 in for that x right there. Okay? So we know that the derivative of log base b of x at x equal 1 is 1. Now let's come at this derivative from a different direction. If I'm going to differentiate log base b of x, that could be found by taking a limit as h approaches 0 of log base b of x plus h minus log base b of x all divided by h. Okay, that's the definition of derivative. And now we're going to take a look at what do we get there if we substitute 1 for x. So limit as h approaches 0, log base b of 1 plus h minus log base b of 1 divided by h. Now, log base b of 1 is 0 because the natural log of 1 is 0. Look at it here on that picture. Minimize, go away. Okay. So I'm now at the point where I can say that the derivative with respect to x of log base b of x at x equal 1 is equal to the limit as h approaches 0 of log base b of 1 plus h divided by h, because log base b of 1 is 0. Moving on. Now my job here is to evaluate this limit we've got. To be able to do that, I'm going to interchange the limit as h approaches 0. No, I'm not yet. Never mind. Instead of dividing by h, I'm going to think about multiplying by 1 over h. And then using the properties of logarithms, I can take that 1 over h and make it an exponent. So I'm looking at limit as h approaches 0 of log base b of the quantity 1 plus h raised to the 1 over h power. And that is equal to the derivative with respect to x of log base b of x at x equal 1. Now I'm going to interchange the limit and the logarithm. Back in section 4.7 was the first time we did that, and that is okay as long as you've got continuous functions. And we do. So I'm going to rewrite this as the log base b of the limit as h approaches 0 of the quantity 1 plus h to the 1 over h power. Ugh, bad parentheses. Now, this limit is e. That's one of the definitions of Euler's number e. So if h is going to 0, we've got a base that's very, very close to 1 raised to a power that's infinite, and that's going to be e. So we can say that the derivative with respect to x of log base b of x at x equal 1 is equal to log base b of e. Okay, now back to one of the things that we said at the beginning. Right here, the derivative of log base b of x at x equal 1 is equal to 1. So I can replace the left side of my equation with a 1. So 1 is equal to log base b of e. Changing that to exponential form, the base is b, the power is 1, equal to e. So we've just found that the base of our natural logarithm is e. So we can say that the natural log of x is the same thing as log base e of x. So there's some proof using some calculus that the base of the natural logarithm is actually e.